Good afternoon, everyone. I hope you guys had a good midterm break. Folks, this is just to give you a recording notice. This lecture is being recorded. If you have any concern, you need to contact me. What we are going to start, joint probability function. Or in some of the books, you will see it as a distribution, joint probability distribution. Distribution. That's what we are going to study today. Joint probability function or joint probability distribution. First, we will look for discrete random variable, and then we will look for the continuous random variable. So I'm going to start with the discrete random variable. Now, as you can see, this is the joint probability. So this means we are going to have more than one distribution, of variables. Or I can say that there will be more one variable, random variable in particularly. Those random variable that we'll assign today will be x and y. So what is the joint probability function or the distribution? This will be the distribution or the probability distribution in particularly for two random variables. In our example, we are going to say them as x and y. If x and y are two discrete, if x and y are two discrete random variables, then the pair x and y is a two-dimensional random variable. If x and y are two discrete random variables, then the pair x and y is a two-dimensional random variable. Now, how we denote a joint probability distribution or function? We have p. We are dealing with two variables, x and y. We have one variable which is x, and the value of this random variable is x. And then we have y. The value of this random variable is y, is equals to, this is also written as p of x, y of x and y. Folks, can you hear me? I have a message. I cannot hear any. Marshad Ahmed. Okay, thank you, Don. I think you need to check your speaker, maybe, Marshad. Okay, thank you, guys. Okay, so we have joint probability distribution P of X of Y. Now this thing, what we call as a joint probability function or distribution of X and Y. It could be any two variable. Folks, I need to move to the next slide, please. We have two conditions that needs to be met in order to define any distribution as a joint distribution. For P of xy of x of y to be a joint distribution, necessary and sufficient is. So we have the first condition is that this probability value P of x of y of x and y, this should be greater than equal to 0, and this is valid for all values of x and y. The second condition is, and this value, the probability of x and y, for x and y. Now you need to pay attention here. The sum of this probability should be equal to 1. Sum of this probability should be equals to 1. Now as you can see, I have two variables x and y, and I'm dealing with the discrete random variable. I will use the summation sign here. Two summation signs. So the first one will be all x, and the second one is for all y. So all values of x and all values of y. This summation should be equals to 1. Now these are the condition for joint probability distribution of function. Okay, I need to go on the next slide, please. Now we will do one example here. In an autopilot, in an auto plant, two tasks are performed. The first stage, welding two joints And the second is tightening 3 bolts. From the past experience, we have following data. For P of xy Now, folks, I'm going to draw a table here, then I will explain you how we read that table. Now, this top is what we called as a y. Let's say this is my variable with the improper tightening bolts. And these ones, these are, let's say, the other random variable, which is x, which are the number of the defective weld. Because I am going to display the values corresponding to each other, here I will just divide this cell and say this is my y values and these are my x values. Now, if I have y is equal to 0 and x is equal to 0, the value comes out to be 0.399. This is a part of your question actually. So I'm just explaining you how you read this table. If y is equal to 1 and x is equal to 0, your probability value given to you is 0.48. We are not calculating it. This is a part of your question. Similarly, if y is equal to 2 and your x is equal to 0, the probability value is 0.02. If my y value is 3 and x value is 0, my probability value is 0.01. Now come here, if you have your y value is equal to x value is equal to 1, this probability value is 0.06. 0.01, 0.008, 0.002, 0.01, 0.005, 0.001. Now again, we are not calculating them, they are the part of your question. So these values, they represent at a given value of x and the y. For example, if I take any value, let's say this 0.08, so this value, let me change. So this value basically is P of xy when your x value is, you go on this side and the x value is 1 here, when your x value is 1, and when your y value is, you go on the top, this is my y value is 2, the probability value turns out to be 0.008. This is how you interpret this. Now again, this is the part of your question. We are not in these probability values. And this thing can also be written as P of xy at 1, 2 is equals to 0.008. Folks, I need to go to the next slide, please. Now he's asking, number one, find the probability. Find the probability when there is no error. The second is, he's asking, find the probability when exactly one error. Now let's start its solution now. For example, we say that x is the number of defective weld. Now, if you go back to your statement, he was saying that this welding, the first is welding two joints. So this means your x value here, this x value should be equals to 1 and 2, right? However, these are the probability when we have the defect there. So if there is no defect, I also have to write down 0 here. I hope this is clear to you. This is the other part of your, when we don't have any defect, this 0 comes. Now similarly, my other variable is y, which is the of improper tightened bolts. Now let's go back to the question statement here. So he was asking, the second is tight 3 bolts. So this means your y value when it is not proper is 3. So it will be 1, 2, 3. And when there is, this random variable will be 0. Now if you look here, you have x 0, 1, 2 and your y is 0, 1, 2, 3. That is the reason your table is indicating the same thing. So your x is 0, 1, 2, whereas your y value is 0, 1, 2, 3. Folks, I need to go to the next slide, please. Since x and y are discrete random variable our conditions of joint probability distribution. Now, what was the first condition? That your P here, which is xy at x comma y, that should be greater than equals to 0 for all values of x and y. For all values of x and y. Now, if we go back to our table here, you can see all the values, they are greater than equals to 0. So this condition is met. Now let's check the second condition. The second condition was probability of x of y is equals to 1, and we take the sum. This is for all x and this is for all y values. Now for x, you know it is starting from x is equal to 0 and it is going up to 2. For y, we know it is starting from 0 and it is going up to 3 of x of y. That is equals to 1.0. Now this term on the left hand side in simple terms, what does it mean? I will start from here and I will add up all these numbers. I will start to add up all these numbers and they should be equal to 1. So if you will add up 0.39 plus 0.48 plus 0.02 plus 0.01 plus 0.06 and your last number will be 0.01. This sum will be equals to 0, and this is what is confirming my second condition of probability distribution. Folks, I need to go on the next slide, please. So hence it is proved that this is the joint probability distribution. Now in the part 1, when there is no error, that means I'm interested to find out when x is equal to 0 and when y is equals to 0. So your joint probability distribution, when x is equal to 0 means to say there is no joint, and when y is equals to 0, this will be equals to your p of x of y at 0 and 0. Now in order to find this, I will go back to my table and see what is the corresponding value when x is equal to 0 and equal to 0. So I'm going back to my table. Now this is the x is equal to 0 and this is the y is equal to 0. So this is my answer, because at this value my x is equal to 0 and y is equal to 0. So this turns out to be 0.39. And that's your answer. Now in the part B, he was asking that there is exactly one error. So that means when x is equal to 1, y is equal to 0, and when your x is equal to 0, your y is equals to 1. So what I'm interested here, I'm interested to find out two joint probabilities here. Probability of x and y when x is equals to 1 and y is equal to 0. The second probability that I'm interested is the p of x of y when my x is equals to 0 and y is equals to 1. Once I have these two probabilities, I just add them to find my answer. Now let's go back to table and we will see at what value of x is equal to 1 and y is equal to 0, what is my probability. So I'm going back to the tables now. So this is my x is equal to 1. This is my y is equal to 0. So I came down here and the value corresponding to this is 0.06. So this is 0.06 plus. Now for this one, the x should be equal to 0 and y is equal to 1. Again, I'm going back to my tables. So at x is equal to 0 and at y is equals to 1, this is my probability value here, 0.48. You add them and you get your final answer 0.54. Folks, I need to go on the next slide, please. Now, just like the cumulative distribution of the discrete and the continuous, we have the joint cumulative distribution. F of x of y, whereas your is greater than equals to your capital X and your y is greater than equals to capital Y. This is what we denote it as f of x, y, because we are talking about the cumulative distribution. Or in other words, this is written f of x of y of x of n, comma y of m. This is equal. I have my joint probability of p of x of y, and because it is the cumulative and I'm dealing with the discrete random variables, I will just take the sum of two. So the first one is x starting from 0 to n, and the second one is for y. Y is again starting from 0 to m. Now if I add up in the previous question, what is the probability What is the ability that there is no more than one defects in each category? Now, by to say I want to find out the joint probability of x and y when my x variable is less than equal to 1 and y variable less than equals to 1. Now by above definition we know that this p equals to p f of x of y. This one is the capital F. F of x of y at 1 and now this one, this is the definition that I'm going to apply over this. I need to have the probabilities of x and y, and I will sum up for x. Now your x is starting from 0 to 1, and the second summation is used for y when y is starting from 0 to 1. Now the next step is just expand this and plug my values. Folks, I need to go on the next slide, please. So this will be probability at 0 and 0 plus probability of 0 and 1 plus the probability of 1 and 0 plus the probability of 1 and 1. Now once you will go back to table and look at the values, it will be 0. Plus 0.48 plus 0.06 plus 0.01 and final answer 0.94. Now up to this point we were studying the discrete random variable. Let's start for the continuous now. Now for joint continuous distribution, let x and y are two continuous random variables, then the pair x and y is also a continuous random variable. A function f of xy at x and y is defined as, folks, I need to go to the next slide, please. P of x of y. Now you just need to pay attention. This equation is a little bit complex, but if you understand how we write it, it will be easier for you. Now my first variable is x, okay, and I'm going to give it a range of a and b. So my x is greater than equals to a and less than equals to b. This is my first variable. And the second variable is y. I'm going to give it a range of c and d. So y is greater than equal to c and less than equals to d. This is my range of this variable. This is equals to, I just mentioned this should be equal to f of x of y, whereas the are for x and y. Now just pay attention again here. You know, I have two variables here. So I will have the two integral because I'm talking about the continuous random variable. The first integral is for my x. So the limit should be from a to b. The second integral is for my y. So the limit should be from c to d. And because I have the integral here, I also need to write down my differentials here. Now, when you write down the differential, the first inner integral comes first. This c and d is related to y, so this should be d of y. It will be wrong if you write down d of x. And the outer integral is for your x. It will be wrong if you interchange these two because the limits are dependent upon them. Now, similar to discrete random variable, the necessary and sufficient condition for f of x of y to be a joint distribution distribution is, now the first condition is f of x of y. When we talk about x and y, that should be greater than equals to 0. Now this for x, which is ranging from minus infinity to plus infinity, and the y, which is ranging from similarly minus infinity plus infinity. This is my first condition here. Now the second condition is this f of x of y for x and y. We will take two integrals here. This is from minus infinity as I discuss here, to plus infinity, and for the y again from minus infinity to plus infinity, and my d of y and d of x. These should be equals to 1. That is my second condition in case of continuous random, the joint probability distribution of continuous random variable. This is 1. Folks, I need to go to the next slide, please. Now we will do one example here. In a healthy individual, this is A, ages between 20 and 29, the calcium level of blood is between 8.5 and 10.5, and the units are mg per liter. The sugar level is between 120 and 240 mg per liter. Now, from past experience, we know that there is a uniform distribution over specific range as it is given as f of x of y into x of x of y is equals to c. Now this is your constant. We don't know its value at the moment, but it is a constant. The first objective is we need to find our c. The second objective is the probability we need to find the probability when calcium level is between 9 and 10 mg per liter, and the sugar level is between 125 and 140. Folks, I need to go on the next slide, please. So what is our first objective here? We need to find our C value, which is in f of x of y. And the second is we need to find the probability when calcium level is between 9 and 10 and sugar level between 125 and 140. What is the solution of this problem? And we will say here that x is the level of, let's say x is the level of calcium, and we know that from our question statement it is ranging between 8.5 and 10.5. And the y is the level of sugar. From our question statement, we know this y lies between 120 and 240. Now, in the part A, we need to find the C. What we will do, we will check our conditions. What was our condition? That f of x of y at x and y, it should be then equals to 0. Now, according to the given question, this thing is also equals to C. The second condition was f of x of y at x and y into d of y into d of x. We will take two integrals here. The first one, outermost, is for x. We know the range of the x is this one, 8.5 and 10.5. So the x integral range will be from 8.5 to 10.5, the outermost. Y range is 120 to 240. So this will be 120 to 240. That should be equals to 1. Now this thing, we know this is equals to our C, as it was given in your question statement. So this is the C of d of y into d of x, and all of these values of your integral, 8.5 to 10.5, 120 to 240, which is equals to 1. Now this equation I can solve and can find out the value of my C. Folks, I need to go to the next slide, please. Now this is the C is the constant, so I can take it out of the, I have two integrals going on here. One is the dy and other is for the d of x. That should be equal to 1. Now the x limit is 8.5 into 10.5. This is from 120 to 240. Now first we will solve, let me change the color here. First we will solve integral. This integral we need to solve first, and then we'll solve our x. So if you recall from your integration and differentiation rules, this integral cancel out by the d, and the leftover is the y variable. Now this equation will turns out to be c. Integral of x will remain the same so far, 8.5 to 10.5, and this will become my y. Now because I have used my integral here, I need to plug in my limits. So it will be limit from 120 to 240 into d of x, that is equals to c of integral from 8.5 up to 10.5. Now this one is the upper limit, which is 240 minus the lower limit 120, and then you get the d of x is equals to 1. Okay, let me that's fine. C is 8.5 to 10.5. This one will be 120 times d of x is equals to 1. Again, 120 is a constant in integral, so I can take that out. It will be c times of 120 integral of 8.5 to 10.5 of d of x is equals to 1. Now the same rule which we were using here, it applies here, that your integral of x will be x. That's because the integral and d cancel out each other. This will be c times 120, and this is my x. Because I have used my integral, I will put my limits. Limits are from 8.5 to 10.5 is equals to 1. Now in the next step, I just need to plug in my upper value minus my lower value. Oops, I need to go on the next slide, please. So this will be c times 120, 10.5 minus 8.5 is equals to 1, and c times 120 times 2 is equals to 1. Now the c turns out to be 140. That is value of my c. So I can say that my function x of y, which was equal to c, is 1 over 240. That's my function. Now in the part B here, so in the part B, he was asking to find the probability when calcium ranges from 9 and 10 and sugar ranges from 125 and 100. That's your part B. Folks, I will go on the next slide, please. Now in the part B, now you just need to pay attention again. It will be a long equation, but it is very easy if you understand how to write it down. So my x is between 9 and 10. That's what I want to find out. And my y is between 125 and 140. That's what we need to find out, our probability. Now this term is equals to f of x of y for x and y. Now, because I am using the continuous random variable, I will take two integral. One is for x, other is for y. So this is my first integral. This is my second here integral. And I know the order of my integrals. This is dy and d of x. So the is 125, the innermost integral, and it will be 140. The x integral, it is ranging from 9 to 10. It will be from 9 to 10. Now I know this is the 1 over 240. We just find out that. And I take its integral from 125 to 140. And this integral is from 9 to 10 into d of y into d of x. Now the same procedure as I did before, this is a constant, it will come out of your integrals. And once you solve this, you get 0.0625. Folks, I need to go on the next slide, please. This is the answer of your part B. Now, similar to the discrete, we have the joint cumulative. We have the joint cumulative distribution. For continuous random variable. Now this will be f of x of y. There is no difference in the formula other than that we take the integral here because we are talking about the continuous random variable. F of x of y is equal to, this is my f of x of y for x and y, and I have two variables. I have two integrals here. The most is for y and this is for x. Minus infinity to x and the minus infinity to y. Now if f of x is equals to the partial differential of f of x over the partial differential of, then for joint probability distribution, your f of x of y at x and y will be equals to the partial differential of f of x of y partial differential of x times your partial differential of y. Okay, folks, I will stop it here. We will do some numericals related to this in the next lecture. If you have any questions, you can please ask me. JPD is the joint probability distribution. Okay, I can write it down here. This term is the joint probability distribution. Is that okay, Tom, with you? Okay, Marshad, sorry if I'm pronouncing your name wrong. Marshad, right? He's asking, can you please give us a hint on 5 of the assignments, sir? Sir, your assignment is your job. Why do you need help from me? Okay, I will give you a little bit hint, but if you have any question for the lecture, please ask me, and then at the end I can give you some hint about that. Okay, for question 4, Al-Zubair. Okay. Is there any question related to the lecture for today? Okay, so we will go with the Marshad question. Can you please give us a hint on question 5 of assignment? Now, I'm not going to tell you the solution of your question 5, of course. What I'm going to give you a little bit hint here. Question 5 of your assignment. Now, if you look at your statement on the lane B, in order to clear the junctions, there could be 10 cars ahead of him. Okay. So I can say that there are 10 cars, and if each car is taking 3 seconds, so how much time will be this? This is your 30 seconds. Now, in your question statement, he also gave you another time, 45 seconds. Let me read the statement of your question. So what is the probability that the driver will clear the intersection in 45 seconds or less? So when we know that 30 seconds is the time which drivers need to clear the 10 cars for 3 seconds in each junction, and 45 seconds is the total time, so you can easily find out what should be your waiting time. You can easily find out your waiting time from this. Now don't ask me either you should subtract this or add them. Now this question is related to the Poisson distribution, and from the statement you have the lambda. If you look here, so your lambda will be 1 over 10 seconds, which is 0.1 per second. and you can just use the Poisson distribution formula, and your value of x is from 0 to 5. I hope this makes a little bit sense. Now, in question number 4, if you have correctly calculated your, which is the part A, now in the part 2, you need to use the Poisson distribution. It is mentioning that it is the time dependent, right? So you will use the formula of Poisson distribution, which is the based on the time. If I recall that correctly, it was lambda t power x over x factorial e power minus lambda of t. This was a formula when you want to find out the probability of your x in time t. That's what you need to use in both part A and the part B. The only difference is in the part A, that should be used for x is equal to 2, whereas in the part B, it should be used for x is greater than equals to 1. Sorry, this is the part B and this is your part C. And you know that because the probability that you're looking to find is greater than equal to 1, so the part C particularly, it will be the probability x greater than equals to 1 in time t. So that should be equal to 1 minus your probability of x less than 1 in time t. So the t is the 5 basically in this question. Okay, so we have some more questions here. Okay, Jeff is saying, I think it should read art is equal to lambda to be consistent with the notes or the text. Yes, I mean, you can do it. I'm just going to give you some help here. Yes, you can have it consistent with the notes, of course. Folks, is there any more question for me regarding the lecture or anything else? I hope this can help you to solve your assignment now. Okay, Sabiuddin is saying, thank you, and 5 wasted a lot of our time. If you pay attention to the lectures, it should not have wasted your time. How difficult is to use the Poisson formula? Folks, if you don't have any more question, I will just let you go. Okay, thank you very much, folks, and have a good weekend. See you on next Tuesday.